So, getting the models, so I didn't really mention, you can download the code directly from here. It gives you these options. You can clone the repository, or you can log in and then fork the repository. If you sign in here, they also let you download this program that I use. It's a desktop version. Keeps track of your own repositories. And then when you fork here, it allows you to send the code back to me. And so using a repository is good because it lets you track the changes on a given file and on the whole. So like if I want to know what has changed in this file, I click on it here and it shows me in color what are the changes from one update to the next. So I can look back at here, see this has changed, that's changed. So this is what I would suggest, is install GitHub and create a fork of that repository. Next topic would be ultrasonic enhancement, and I would skip that. Things to add to the models. This can be discussed in much greater detail since you're doing some kind of project. You can have different refrigerant adsorbent pairs, I should say. You can try to estimate, compute the heat exchange coefficients and use those as inputs rather than hard-coded estimates. So in the model as it is now, they're just put in there. There are some values that seem to fit or they're taken from literature. And then you can use a non-equilibrium model for the mass transfer. So something that shows you that there's a mass transfer rate depends on not only the temperature, pressure, but also some geometry. So there's a parameter that explains the mass transfer resistance based on more physical factors. So I'm excited to see what you can come up with, and I'm willing to help, happy to help, and hopefully can be a little bit faster responding than I have been in getting this information to you. And then just going back to a couple of things you can look at. This document shows some of the mathematics calculations that are kind of skipped over in that dissertation. And then also this comparison of the pressure functions is in here, and a little bit of discussion about this process for optimizing the cycle step times. And so this was a really preliminary results kind of thing for me. And then if there's this, what I call literature review, that's, like I said, just some notes that refers to a couple of other things you can read. The Glusenkamp dissertation is a very good one to look at. And then this book by Ruixu Wang, Liwei Wang, and Jingyi Wu. It's a very in-depth look at all aspects of adsorption, cooling particularly. And there's some other papers in here. Good to look through all the literature, and Sumi has some literature as well. Lots of stuff. And these are the results. If you're interested in some of the ultrasound applications, I just pulled some of the data from one of those papers. I didn't really create a new model, but I just did this study based on their own data using my model. And so this must be in a file somewhere. I can get that to you as well. And that's all that there is from those two. So finally, that's all there is. Good luck. Hope to hear from you, and I will probably not force you to watch this whole thing because it's very long and I don't know what I'm talking about. So maybe if I go through this a second time, I'll at least have my thoughts together in this document to help me. So, bye.